Now let's make an exercise where we compute by hand the homogeneous transform matrix in 2D of a set of coordinate frames. Actually, uh, we are interested in computing by hand the homogeneous transform matrices of coordinate frame 1, coordinate frame 4, and coordinate frame 2. Okay? So, well, sorry, in that order 1, 2, 4. I'm not happy with coordinate frame 3 because the origin is at a decimal position, and okay, that will spoil the clearliness of the exercise. So in order to do that, I will add a page after this. Okay, and just write the wording. Okay, compute the homogeneous transform matrices T1 0, T2 0, and T4 0 of the previous picture or image. All right. So, first of all, we are talking about zero, but someone might say, okay, where is the zero? Well, if the zero is not expressed explicitly, the zero frame is the one that we see at the grid as the grid of the plot. Okay, so this is the zero frame, right? So now let's use geometry. Well, I have to point out something. It's also important to know that this is 30 degrees, okay? This angle is 30 degrees. Now let's compute 0, T1. Okay, so to compute the homogeneous transform matrix, we have to know exactly what are the displacements and rotations that have to be performed on the zero frame to get to 1. So to get from 0 to 1, we have to displace the origin. Now let's take a look. I'm sorry, I did a mistake. I was talking about this, but the origin is right in here, okay? I hope I don't have to restart the video because of that. I hope you will excuse me. And we have that to get from 0 to 1, we make a displacement of 1 unit in the x direction and 2 units in the direction, to get to the origin of 1. So to get from 0 to 1, we translate or we displace we translate 0 along the 1, 2 vector. This is in coordinates of 0. Then we rotate around the resulting coordinate frame, okay, around, and I will write that because it's important. The resulting frame, the resulting from the first displacement around the origin of the resulting frame plus 30 degrees. Would you be okay with that? So first we displace along this vector, and then we will have this coordinate system, and from then we will rotate plus 30 degrees. So from that information, so x1, I'll use now highlighting pen. So from x1, y2, and then theta equals 30, we compute the homogeneous transform matrix. And what was the formula? Well, if the sense of the displacement and the rotation is properly defined, then we will just have to write cosinus 30 minus sinus 30 sine 30 cosinus 30. Okay, and then zero. Oh, what happened here? Okay, oh well, the computer decided that it was a perfect circle. It doesn't matter. And now, what is missing? Well, the displacement vector. Okay, and that is the homogeneous transform matrix. Remember that this matrix will transform coordinates from 1 to 0. Now, second question, sorry. We will erase unnecessary information from here. Okay, right, this is not necessary. Over here, yeah, we still need this information, this being 30 degrees, okay. And now we will focus on this coordinate frame. So what is G20? Well, we'll make it quicker. What is the displacement from the origin of 0 to the origin of 2? Well, we have to displace 2 in the x direction and 1 in the y direction, okay? And then we have to make no rotation whatsoever. So we will write here G20 equals. Now the displacement vector, as we have seen, is 2, 1, right? Is that okay? So the displacement vector is 2, 1, and then we have a 1 here, a 0 here, a 0 here, and the rotation is 0. The rotation 0 means that whenever we have a cosinus of 0, a minus sinus of 0, sinus of 0, cosinus of 0, we can also erase all this and substitute that by the exact value, which are in fact 1, 0, 0, 1. All right, and observe this part of the matrix is the rotation matrix, and actually the rotation matrix here is the identity matrix, and that is clear. When there is no rotation, the vector before the rotation should be the same as the vector after the rotation, and this is obtained. This happens only when we are multiplying by the identity matrix. Okay. So the final result is, or the final question is, compute the homogeneous transform matrix of 4. And in order to do that, again, we have to find out what is the distance in the x direction to 4, which is 3, and the distance in the y direction, which is also 3, right? So if with these two numbers and the 30-degree angle in here, we come to the conclusion that the homogeneous transform matrix from 4 to 0 is the one corresponding to a translation of 3, and then the cosinus of 30 minus sinus of 30, sinus of 30, and cosinus of 30. And this, okay, I didn't fill it in here, but this would lead us, okay, this is important, okay, P1, let's have to correct this and set that P1, and then this matrix that we have just computed gives us the change of coordinates from P4 to P0, right? Okay. Just a reminder, I will not stop saying that, okay? Important that the homogeneous transform matrix is computed using the information from geometrical displacements. But the geometrical displacement has to be defined in that order, okay? So the number that I'm writing here, 1, 2, must be the displacement that has to be done, in this case from 1 to 0, as the first motion and then the rotation, okay? If I define the displacement in the other sense, that is, if there is first a rotation on 0 and then a displacement, then those values will not be the ones in the matrix, okay? So in general, making a displacement of 1, 2 on the original system and then making a rotation of 30 degrees will not result in the same coordinate frame as making first a rotation of 30 degrees and then a displacement of 1, 2. Okay, so the order in which these operations is done will result in a different coordinate frame and in a different matrix. So we must keep in mind that in order to compute the MHG, the operations have to follow that order. First, translation or displacement or linear displacement, linear and that's first, and second, rotation. Could someone give me the information all the way around? I mean, if someone tells me that first a rotation of 30 degrees is made and then a translation of 3, 2 is made, is that logical? Yeah, that could be logical. Someone could define the position of a reference frame like that. The only thing I'm saying is that that information will not be the one that I will use to build the transformation matrix, okay? It is not built like that. To build the transformation matrix, I need the first the displacement and second the rotation. Okay, well, I will not insist in that because I'm becoming redundant. That's all for now.